So a couple of you emailed me about the last two questions in that sampling distribution quiz, the one about normal curve sampling distribution. And this is a question number 12 out of the My Open Math assignment. One of your works, one of you people did this. So let's talk about this. So I know this is about a quantitative variable right here. Let me get a pointer going. I know this is about a quantitative variable because they're telling me a mean and a standard deviation. If it was about proportions, it would be no mean and standard deviation listed. We'd have to calculate that. So because they're telling us that the distribution of tips is nearly normally distributed, that means the sampling, remember those piles of X bars. We go out and get many, many samples of size 25, and we calculate the average tip and make a graph of it, it'll look like a normal curve, right? And that normal curve will be centered at the population average, which in this case is $15.25. Okay. And then to get now, if it's just a single person, a single tip would have to use that standard deviation. But because we're talking about an average, remember, this is going to be the distribution of X bars, all the possible X bars we can get, all sample meanings from samples of size 25. It'd be a pile of X bars there, right? And how those pile of X bars vary is we use this symbol for the standard error, we call it mathematically. It's basically the standard deviation for all the X bars. And so the way you do that is population standard deviation divided by the square root of the sample size. So for this one, and see this person, yes, it's normally distributed. I don't know if that was a guess, or you saw it normal, so it ought to be normal. These two conditions you got to meet if the parent population is normally distributed, the sampling distribution will be normally distributed. I don't know if you remember that graph that we looked at. I showed you how it pulled all the averages, pulled the numbers out of the distribution. If it was a normal parent population, the two distributions were normal. It didn't matter on the sample size. But if it wasn't a normal distribution, you needed to have a big sample, more than 30. So because this is a sample size of 25, that's questionable. But because the parent population is normally distributed, the sampling distribution is normally distributed. If this were 40, sample size of 40, and this was skewed, well, then the sampling distribution would also be normal because this is bigger than 30, okay? So hopefully you get that down because you'll see that again. But to answer this question, we know that the parent population is normally distributed, so the sampling distribution will be normally distributed. So that means we can use this technique. And to get the standard deviation, what this question is looking for is we're going to take that parent population standard deviation divided by the square root of the sample size. So that's going to be 4.68 divided by 5. And I don't know what that answer is. Where's my calculator? It's less than 1, right? So got 4.68 divided by 5. Whoops. 4.68 divided by 5. I'm getting 0.936. So that's what should have gone here. The sampling distribution of X bars. That's how you calculate the standard deviation for that sampling distribution of X bars. Now, what's the probability that the next 25 parties notice same sample size will leave an average tip of 16.58 or more? So here's a well-labeled sketch. I put the mean here. I'm going to change the color up here. And I want to know what's the probability of getting an average of 16.58 or higher. Okay, so what that means, I want to use a normal CDF, either David Lane, or if you've got a graphic calculator with you, you can do this. And if we're going to use it, well, let's do a graphic calculator because some of you do have this. You have the one that you just signed out. So let me see. Let's come back and find. Come on. Find. I get to pop up here. Let me stop this share for a minute. Okay, so we're at David Lane. I might have said the calculator, but we'll come back and look at the calculator. This is what popped up for me. So there's my well-labeled sketch. And now I want to figure out the probability of getting a sample of 25 tips having an average higher than 16.8. So the mean for this distribution is 15.25. The standard deviation for this distribution is the 0.936. And then we want to know above 16.58. That's the probability of getting a sample of 25 tips having an average higher than that value. Okay, not less than 5%, so it's not unusual to get that. It would be an unusual thing. Now, if it was a less than situation, would look same math, except we'll go below. So here's the well-labeled sketch. Don't forget to use your new standard deviation, and then make sure you're looking at the right area. Now, what if you're using a graphing calculator and you'd rather use a graphing calculator? So with a graphing calculator, what you can do, you can do second distribution and do normal CDF, number 2. And remember how our low was the sample mean of 16.58? And then our upper is going to be some huge number. I'm going to type in a 1 with a bunch of zeros. We want to make sure we get that whole upper tail. Got to go far enough out to get it. And then our population mean is 15.25. And then our standard deviation, which we calculated, was 0.963 or 36. Okay, and then we'll click and paste it and get the answer. And notice that's the same as what David Lane said. Okay, so that's the probability. That's how you do it in both platforms. I hope this helps you answer that question. Go back and take a look at your My Open Math work that you did.